Hello grade 8s, and please have your matchsticks ready. Just going to need a few of them to get going with this. What we're doing in this one is we're deconstructing picture patterns. And it's less about going, I definitely know that they're going to be however many matches in shape 3, but rather deconstructing it in multiple different ways. So here we go. Here's our example, and I'm purposely using the same example that's in your workbook. So we've got one shape given, shape 3, and it looks like that. And we're given shape 5 that looks like that. Okay, and now we're going to say, how did that shape get constructed? Was it made with a whole lot of different squares or C's or whatever it's going to be? So let's look at a few examples. One way we could deconstruct this is we could say, let's start with one matchstick. So that's our one that we're going to start with. And then we're going to make these kind of backward C's. So if I were to make shape number 1, I would have had starting with 1 and then 1 backward C. If I'm going to make shape number 3 that's given to us here, I'm going to say, well, that's easy for that one. I'm going to start with my 1 matchstick, and then how many backward C's am I making? And I hope that you're fiddling with your matchsticks as well, putting them all right in these little backward C's in it. So we could say, okay, so if I did it for shape, let's just look at shape 3 and 5. So for shape 3, we had our 1 matchstick to start with, and then we said, well, how many of these backward C's do we have? Well, we've got 3 of them. And how many matchsticks in each little backward C? 1, 2, 3 of them. So there are 3 of them. Let's see what happens we do for shape number 5. So for this one, we're starting with 1 matchstick, and then let's just move all of these over, and we're going to make a whole lot of backward C's. That was our deconstruction. 1 plus a backward C. So let's move that there, that there. Oof. Space is at a premium here. Okay, let's move them along a little bit. Come on, the matchsticks. Move there, there. Okay, there, we just squeezed it in. So for shape 5, not for that bit there, we've got 1 matchstick, and then how many backward C's do we have? 1, 2, 3, 4, 5. I see. Okay, cool. So we got, for shape 5, we've got 1. That's the one that started off. Ooh, there we go. And then we said we've got 5 of these backward C's. We've got 5 times how many matchsticks in each backward C? There are 3 of them. So if I asked you how many matchsticks using this deconstruction, if we were to look at shape number 10, I don't have enough matchsticks or space or time to make that now. So let's just see how many matchsticks would we do. Well, we'd start with our 1, right? And then we'd say, well, how many of these backward C's are there going to be? Well, in shape 3, there were 3 of them. And in shape 5, there were 5 of them. So in shape 10, they're probably going to be 10 times 3, 10 of those backward C's. So we could work that out and say, okay, well, 1 plus 30 gives us 31. If in 5, we had 5 times 3, that was 15, plus another one, 16. And in this one, we had 3 of these. So we said 3 times 3, that's 9, plus 1 gave us 10. So if we were to look at any shape, I'm going to call that n, how would we build that up? We'd start with our 1. Then we'd add, how many backward C's would we have? Well, if there were 10, we'd have had 10. If there were 5, we would have had 5. If there were 3, there were 3, so we would have had n. So we could have said 1 plus n times 3. So I can give you any shape, and you can say, okay, in shape number 100, they're going to be 1 plus 100 times 3. Okay, so that's one deconstruction. Let's run through a few more. As I said, the purpose here is to deconstruct it in different ways, not to come up with one rule, but the ability to come up with lots of rules and then understand somebody else's. So I'm going to scroll down, give it some space, and say, okay, let's look at another one. I might actually know. My starting point is going to be, so let's reset this all. So you're given shape 3, and we're given shape number 5 like that. Okay, so we're back to where we were, and hopefully we're still just within there. Okay, so I'm looking at here is getting a bit closer to the end. So we've got these two shapes, shape 3 and shape 5. So what about this time if we started with a square and then each time we added those backward C's that we talked about? So if I had a square and then added this is how I would make one of the shapes. So for shape 3, we're starting with a square and we're adding backward C's. So we're going to say, great stuff, let's start with our shape, and we're saying we've got one square and two backward C's. So we're starting with shape 3, we're going to start with a square, which is 4 matchsticks, 1, 2, 3, 4, and then we're going to add in these backward C's. So in this case, there are 2 of these backward C's. So we've got 2 times 3. And we still should get the same number of matches. The number of matchsticks hasn't changed. So we've got 10 matchsticks. That's what we expect. That's what we got in the first place. That's what we still got, 10 matchsticks. Now, what happens if we did a similar deconstruction for shape 5? So let's move those along so they're out the way and say we're going to start with a square and we're going to make these backward C's. There's one of them, there's another one, there's another one, and there's our last one, just squeezing in. Okay, so we've got one square and 1, 2, 3, 4 backward C's. So for shape 5, we've got our squares, so that's 4 matchsticks, and we've got 1, 2, 3, 4 of these backward C's, which have each got 3. Same number of matchsticks, so we should get 16. Well, let's check it. 4 times 3, because we're going to do multiplication first, is 12. 12 plus 4, 16. One of the two, 16. Definitely 16 matchsticks here. Okay, so if I gave you in our previous example, we said, what about 10 matchsticks? 10, at least shape 10. How many matchsticks would we have? Well, in this case, let's still start with a square, 4. And how many backward C's would we have? Well, in shape 3, we had 2 backward C's. In shape 5, we had 4 backward C's. So in shape 10, we'll just have 9 of them. So we'd have 9 times 3, 9 times 3, 27, 27 plus 4, 31. Looks like a different rule, but we're getting the same answer, because it definitely will work out. It's just a different way of looking at it. So if I said to you, what's the general rule? What's going to work for n matchsticks? We're going to start with our square. That's 4 matchsticks. And how many of these backward C's are we going to have? We're not going to have n this time because shape 3 had 2. Shape 5 had 4. So we're going to have n minus 1, because that will be 1 less than whatever shape number we're on. And we're going to multiply that by 3. Different rule, same result. And that's the important bit. Let's run through another way. Okay, so we've got our first shape here, shape 3. We've got next shape, and let's reset it all here. And we could say, I'm going to skip the third one in the workbook. You can work through that, and rather run through the fourth one, because it's a little bit different in how it's built up. In this case, we can say, in shape 3, I'm not going to build it up using these backward C's anymore. I'm going to build it with these squares. So when I say shape 3, it almost looks like you've got 3 of these squares. But if we did do 3 squares, like that, if we broke it up and got that, you see we're doubling up on these cross pieces here. So we could say, okay, so for shape 3, we've got 3 squares, but we've double counted these ones. So if we had 3 squares, we'd have 3 lots of 4, because that's how many we said we've got in a square. So we've got 3 lots of 4, but we've double counted 2 of these. We've double counted 2. Okay, let's see how that would work out for shape 5. If we said, let's break it up, we've got these squares here. square plus square plus square. Let's really give ourselves some space here. Square, 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 square. But if we were to turn these into squares, I would have had to add in these matchsticks. 1, 2, 3, 4. So we're going to have to subtract 4 this time. So for shape 5, we're saying we've got 3 of these squares, which have each got 4 matchsticks, and we're going to have to subtract 4. And let's see how we can get that 4. I don't just want to write 4. How does it relate to the 5 at shape 5? So here we subtracted 2 because we double counted 2 of them. In this case, shape 5, we've double counted. How many of these in-between bits are there that we've double counted? Well, there were 4 of them. So we're thinking, well, it related to 5, it's 1 less. So it's 4 because it's 1 less than that. In the case of 3, it was 2. In the case of 5, it's 4. So if we were to look at shape 10 in the same way, we would surely have 10 of these squares. So we'd make 10 of these squares as we've done. So we make our little squares and we make 10 of them. But how many of these in-between bits have we counted extra? Because there are not 2 matchsticks there, there's actually only 1. Well, we've counted 9 of them extra. Let's just check these that they're working. 3 times 4, 12, 12 minus 2, 10. 3 times 4 is 3 times 4. Oh, there's a little mistake. There weren't 3 of those squares. We said there were 5 of them. 5, 1, 2, 3, 4, 5. Okay, so we had 20. 20 minus 4 gives us 16. And in this case, 10 times 4 gives us 40. 40 minus 9 gives us 31. So our rule's still working. Feels a bit more complicated, but that's good because you want to come up with a whole lot of different rules. So in this case, if you asked for the rule for any shape, for shape n, we're going to say, well, this 5 was 5, this 10 was 10, so we're going to say n times 4, there are n of these little squares, but how many have we double counted? So we need to subtract how many? Well, if there were 10, we double counted 9. If there were 5, shape 5, we double counted these 4. So we need to subtract n minus 1. And that's another way of looking at it. No need for any algebra. Not going to compare that to our previous rules and see why they're the same. Just happy that definitely is working out to be the same. You can try it with any shape. Try it with shape 2 and see if our rule still holds. So that's going to be the purpose of this exercise and this part, which is challenging in a lot of ways, because you might see one rule quite quickly and go, oh, I saw it with the square and I added the backward C's. But now the book says something about I can see a row of these top bits and a row of the bottom. How do I see it in another way? And please, please, please just chat to each other and see, oh, how did you deconstruct that one? That's going to be the purpose. So again, you can hand them all in. This time I might share some of the different deconstructions on the website that you've come up with. And good luck, have fun.